Hello friends, welcome back to my channel. Today I would like to share with you the topic shapes of molecules. At first, let's look at VSEPR theory. Valence shell electron pair repulsion model can be used to predict the shapes of many molecules and polyatomic ions. This theory assumes that each atom in a molecule will achieve a geometry that minimizes the repulsion between electrons in the valence shell of that atom. When determining the shape and bond angles of a molecule, the following VSEPR rules should be considered. Valence shell electrons are those electrons that are found in the outer shell. Electron pairs repel each other as they have the same charge. Lone pair electrons repel each other more than bonded pairs. Repulsion between multiple and single bonds is treated the same as for repulsion between single bonds. Repulsion between pairs of double bonds are greater. The most stable shape is adopted to minimize the repulsion forces. The order of repulsion is therefore lone pair greater than lone pair greater than bond pair. If there are two electron groups, molecule with two bonded atoms and with no lone pairs of electrons, example BeH2, the central atom beryllium contributes 2 valence electrons and each hydrogen atom contributes 1. The Lewis electron structure is therefore given below. Both groups around the central atom are bonding pairs. No lone pairs. The arrangement that minimizes repulsions places the groups 180 degrees apart with two bonding pairs. The molecular geometry that minimizes repulsion in BeH2 is linear. Another example is CO2. The central atom carbon contributes 4 valence electrons and each oxygen atom contributes 6. The Lewis electron structure is given below. The carbon atom forms 2 double bonds. Each double bond is a group. So there are 2 electron groups around the central atom. The arrangement that minimizes repulsions places the groups 180 degrees apart. With 2 bonding pairs on the central atom and no lone pairs, the molecular geometry of CO2 is called linear. If there are 3 electron groups, example BF3, the central atom boron contributes 3 valence electrons and each fluorine atom contributes 7 valence electrons. The Lewis structure is represented here. All electron groups are bonding pairs. We see that with 3 bonding pairs around the central atom, the molecular geometry of BF3 is trigonal planar with bond angles of 120 degrees. If there are 4 electron groups, example for that is CH4, methane. The central atom carbon contributes 4 valence electrons and each hydrogen atom has 1 valence electron. So the full Lewis electron structure is given below. There are 4 electron groups around the central atom. Repulsions are minimized by placing the groups in the corners of a tetrahedron with bond angles of 109.5 degrees. All electron groups are bonding pairs and with 4 bonding pairs, the molecular geometry of methane is tetrahedral. Another example is NH3, ammonia. In ammonia, the central atom nitrogen has 5 valence electrons and each hydrogen donates 1 valence electron, producing the below Lewis structure. There are 4 electron groups around nitrogen, 3 bonding pairs and 1 lone pair. With 3 bonded pairs and 1 lone pair bond pair interactions cause the bonding pair angles to deviate significantly from the angles of a perfect tetrahedron. So the molecular geometry is trigonal pyramidal. However, the H-NH bond angles are less than the ideal angle of 109.5 degrees because of lone pair bond pair repulsions. Another example is H2O, water. Oxygen has 6 valence electrons and each hydrogen has 1 valence electron, producing the given Lewis electron structure. With 2 bonding pairs and 2 lone pairs, it has a total of 4 electron pairs. Due to lone pair repulsion, lone pair bond pair and bond pair interactions, there is a significant deviation from ideal tetrahedral angles. There are 2 nuclei about the central atom, so the molecular shape is bent or V-shaped with an HOH angle that's even less than HNH angle in NH3 because of the presence of 2 lone pairs of electrons on the central atom rather than 1. If there are 5 electron groups, for example in PCl5, phosphorus has 5 valence electrons and each chlorine has 7 valence electrons. So the Lewis electron structure of PCl5 is shown below. All electron groups are bonding pairs, and since there are no lone pair interactions, the molecular geometry of PCl5 is trigonal bipyramidal. The molecule has 3 atoms in a plane in equatorial positions and 2 atoms above and below the plane in axial positions. The 3 equatorial positions are separated by 120 degrees from one another, and the 2 axial positions are at 90 degrees to the equatorial plane. If there are 6 electron groups, for example in sulfur hexafluoride SF6, the central atom sulfur contributes 6 valence electrons and each fluorine atom has 7 valence electrons. So the Lewis structure is as below. There are 6 electron groups around the central atom, each a bonding pair. The geometry that minimizes repulsions is octahedral with a bond angle of 90 degrees. Another example is carbonate ion, CO3 2-. The central atom carbon has 4 valence electrons and each oxygen atom has 6 valence electrons. The Lewis electron structure of one of the 3 resonance forms is represented as shown here. All electron groups are bonding pairs. With 3 bonding groups around the central atom, the molecular geometry of CO3 2- is trigonal planar with the bond angle of 120 degrees. Another example is sulfur dioxide SO2. The central atom sulfur has 6 valence electrons, as does each oxygen atom. With 18 valence electrons, the Lewis electron structure is shown below. There are 2 bonding pairs and 1 lone pair in SO2 and have 1 bond pair interaction and 2 lone pair interactions. The bonding pairs and lone pairs repel each other electrostatically in the order bond pair repulsion is less than lone pair repulsion less than lone pair repulsions. The molecular geometry is described only by the positions of the nuclei, not by the positions of the lone pairs. Thus, with 2 nuclei and 1 lone pair, the shape is bent or V-shaped with bond angle less than 120 degrees. Another example is hydronium ion H3O+. The central atom oxygen has 6 valence electrons and each hydrogen atom contributes 1 valence electron. Subtracting 1 electron for the positive charge gives a total of 8 valence electrons. So the Lewis electron structure is shown here. There are 4 electron groups around oxygen, 3 bonding pairs and 1 lone pair. So the molecular geometry is trigonal pyramidal with the bond angles less than 109.5 degrees. That's all. Thank you so much for watching this video.